Fellow students, dear colleagues, esteemed chair members, I am very glad to be here. Actually, I am very honored and grateful to be here. This is my 4th year in a row to be a participant of KGH or KGH Congress, but the 2nd year in a row as a lecturer. I would like to thank Professors Marija and Branko Todorović on this opportunity. I will try to be very brief, and I will give you a presentation of the paper Reconstruction of Historic Building and Verification of its Energy Sustainability. I would like to introduce one of the authors, that is Professor Jelena Ivanović ŠEKULARAC, Jasna ČIKIĆ TOVAROVIĆ, Nenad ŠEKULARAC, and myself, Miloš Čokić. I am a PhD student at Faculty of Technical Sciences in Novi Sad. So, this paper analyzes the possibility to apply energy refurbishment measures in restored historic buildings in order to ensure its reuse. The main objective of this paper is to find an appropriate methodology for the structural restoration of historic buildings, their reuse and sustainable energy refurbishment in accordance to conservation principles, which is very important from the architectural aspect. In this way, we can give a new life to a building. The subject of this research and analysis is the Hay Barn. The Hay Barn is the part of Hay Barn complex, which is the property of Hilandar Monastery on Mount Athos in Greece. The main objectives of this research were to improve energy efficiency and apply reusable energy sources, preserve environmental protection, and maintain authentic look and materialization of historic building. Assessment and analysis of energy refurbishment were carried out through simulation and analysis of 5 different models, via BPS method and energy efficiency optimization. On these images you can see the location of the building, actually of the site where is the building located. It is in northern Greece on Mount Athos. Mount Athos has a specific location. It is situated on a secluded inaccessible peninsula Halkidiki in the northern Greece, as you could see. It has no land route, it is surrounded by the sea, and the only way possible to access it is only by ferry. Mount Athos is very specific in a way, not just because of its location, because it's a unique monastic country and has the autonomous status within the Greek Republic. The Hay Barn, the building that was subject of the research, is a part of Hay Barn complex, as I already mentioned, which is the part and is situated near the Hilandar Monastery. I believe you all have heard of Hilandar Monastery. Hilandar Monastery is for centuries the most important cultural and religious center for the entire Eastern Orthodox Church. Mount Athos and its monasteries have been on the list of the World Heritage Sites since 1988. And one also very important thing, Hilandar Monastery is one of the most important testaments of Serbian architectural heritage. As I already said, the Hay Barn complex is situated near the access road to Hilandar Monastery, and it was built in the first part of 19th century. Before the restoration in 2006 took place, the Hay Barn complex consisted, and still is consisting, of 3 objects: the stable, mule keeper's house, and the hay barn. The hay barn was the subject of this research and analysis. The restoration of the Hay Barn complex was performed in accordance with conservation requirements, which is very important because of its cultural heritage. as I said, the authentic look was preserved and all the construction methods and materials used in restoration were in accordance with the concept of reversibility. It means that at any given time we can bring back the construction's look in prior state without damaging it, which is also important thing. Sorry. On these two images, you can see the whole hay barn complex before and after the restoration in 2006. So, in our research and analysis, we concluded that with our established goals, we will need the energy for heating, energy for cooling, and electric energy supply for lighting, electrical appliances, and sanitary hot water. Also, we analyzed the possibility to apply renewable energy sources such as geothermal resources, biomass, and solar power. When we talk about the simulation and the models, the weather data that was used for this simulation is the weather design data for the city of Kavala, which is located near to Mount Athos, and it has the most, how should I say it, accurate, appropriate weather design values for this object. Before restoration in 2006, the hay barn used to be a tall building for hay storage, and it had perimeter walls which were extremely high and made of roughly dressed stone and rubble. For this research and analysis, we used 5 different models, and simulation and analysis were performed in Bentley IcoSim Energy Simulator, which is integrated with Energy Plus. After the restoration in 2006, as you can see on this picture of the model, the original space was horizontally divided into 3 levels. All the facade walls were thermally insulated from the inside, which is very important because the hay barn needed to keep its authentic look. The ground floor was also reconstructed and thermally insulated, and also the ceiling area on the last floor. Also, the new wooden framed windows were placed, and front door of solid wood is completely new, and they are placed too on the building. The roof structure is a wooden structure, and it's covered with plastered stone plates. Once again, the authentic look of the hay barn was preserved. Heating was installed, and the building was turned into a dormitory for visitors. When we talk about the models, the building that was restored in 2006 was represented through Model 1. Model 2 represents the improvement in accordance with maximum benefits, but without major interventions and construction works, which means that we only have thermally insulated the attic area over the existing ceiling layers. Also, from models 2 to 5, only without model 1, we replaced all windows with new wooden framed windows. When we talk about models 3, 4, and 5, those models include major interventions such as thermal insulation is added to the floor and to the peripheral walls, and all rooms are heated except for the attic area. Also, we wanted to air condition all bedrooms. But I will mention it again, the hay barn will keep its authentic look in accordance with conservation requirements. So, on this image you can see the layers of construction elements that were used and integrated in simulation models. You can see the facade walls, and you can see some properties of the elements. On this image we can see attic floor and ground floor for all 5 models. The parameter values and schedules for heating, cooling, occupancy, lighting, electrical appliances and hot water systems were adopted with compliance with the user's needs, which were very specific because it is a structure which, how should I say it, its visitors come there for spiritual peace and prayer, and they don't have usual life schedules or behaving. The air change rate value was set to 1. We decided to take the value 1 for all 5 models, which is used for refurbished old structure with good air tightness. Electrical energy gained from photovoltaic panels is used for energy requirements for air conditioning, lighting, electrical appliances and hot water systems. And finally, you can see some results of our simulation here on the chart and in the table. As you can see, we have a noticeable decreasing trend for heating energy needs, and we have also decreasing trend for cooling energy needs, but you cannot notice it on the chart. You can see it only in the table because it is a small percentual difference between the values. You can see it here. These are the charts that represent annual energy savings for total energy demand, heating energy demand, and cooling energy demand. Referent models for total and heating energy demands are models 1, actually model 1, and for cooling it is model 3 because we didn't include cooling energy demand calculation in first two models. Also, the part of our research and analysis was the possibility to use renewable energy sources in our simulation and our research. We knew that there was existence of geothermal water on the site, but the analysis and measurement shows that the water is hard and it cannot be used as a renewable source of energy. Because of that, we chose the biomass as a primary source of energy for heating. Wood chips as the source of energy meet the requirements of environmental protection and reduction of CO2 emission, which is very important. So we use the value of 3,500 kilowatt hours per ton of wood chips to convert annual energy consumption for heating to required biomass amount, and you can see it on the chart. Okay. So for other energy needs such as cooling, electrical appliances, lighting, and hot water supply, we thought that we can use PV modules. So the main objective of photovoltaic module technology was to obtain maximum solar radiation to supply objects with necessary energy. It was planned to set PV modules in a secluded place near the complex at appropriate distance from the monastery. PV modules used in calculations are Samsung LPC 2050 SM. So, after our calculations, we established that the annual energy we can supply the object with annual energy needs for cooling, lighting, hot water supply, and electrical appliances, but when we look at it on the monthly basis, as you can see, we have a problem in July and August because we need more energy. So, as you can see, the calculated total power output meets the requirement of total annual electricity demands, but it is not possible to obtain all the required energy during these months, July and August. There is a lack of roughly 40% of electricity in July and in August. So, for further research, we should look for an alternative to supply this object with necessary energy. But what did we conclude from our research? The need for additional accommodation for a growing number of visitors shaped the restoration and adaptive reuse of demolished buildings within the hay barn complex, transforming them into lodgings. The newly restored hay barn building is a link between cultural heritage and modern demands, and in order to reuse historic buildings and increase their energy performance, the following procedures are to be carried out during the restoration works. We need to determine the level and type of restoration and refurbishment considering the analysis of current condition of historic buildings. Also, we need to choose appropriate construction measures for energy refurbishment and reuse in accordance with conservation requirements. We need to implement the principles of energy management in order to reuse renewable sources of energy and find the best solution to annual energy demands and energy savings in this isolated site in accordance with energy efficiency and environmental protection requirements. Restoration and reuse of protected historic buildings require a specific individual approach to each historic building and application of energy efficiency measures. Energy saving implies the following construction measures in accordance with conservation requirements: the installation of thermally insulated cladding, replacement and installation of adequate windows and doors. The application of these construction measures as well as renewable sources of energy significantly increase energy efficiency of historic buildings. The main contribution of this paper is practically testing and evaluating achieved results in energy refurbishment using the energy efficiency principles of restored historic buildings. And at the end, this evaluation was carried out using various restoration models via BPS method in accordance with conservation requirements and authentic preservation principles applied to hay barn complex. So, briefly, we tried to refurbish an old historic structure, but the main goal was to keep its authenticity, and in some way we need to supply it with necessary energy to provide better living for its residents. I hope I was brief and that it was interesting. Thank you for your attention and time.